All right, order of magnitude. Sometimes order of magnitude is called just magnitude. All right, it's the power of 10 that is the closest approximation to a given measurement. I'm going to give you some examples here. Basically, it's a estimation technique to come up with how big is a number. So, and to do order of magnitude more rigorously, mathematically, you always put the number in scientific notation. Here's some examples. That's the best way to do this. The radius of the Earth. By the way, it's around 4,000 miles. So kilometers are a little bit vague to you probably. Maybe not, I don't know. But miles I can relate to. We just did how far you went in a year. And by the way, that one we just did, you could have done it in kilometers. I just did it in miles because that just makes more sense to most people in the United States. So for kilometers there, yeah, you'd have to multiply that by basically 1.6. And that comes out to be like 100 to 120,000, 130,000 kilometers. All right, but back to the order of magnitude. The radius of the Earth, 6,378 kilometers. So to an order of magnitude, this number is closer to 10,000. 6,000 is closer to 10,000 to 1,000. This is a gross or a rounding technique just to get us ballpark numbers to compare large or small numbers that have, we want to compare them, which we'll get to in a minute. So for example, in this case, the radius of the Earth. The radius of the Earth is around 10,000 kilometers. It's 10 to the fourth. So this right here, this 10 to the fourth kilometers will be called, what's the order of magnitude? It's about 4,000 miles. So in miles, 4,000 is close to 1,000. It'd be an order of magnitude of 10 to the third miles. If you had to put that into miles, the order of magnitude in miles, about 4,000 miles is closer to 1,000 miles. So the order of magnitude in miles would be 10 to the third, or 1,000 miles. Here's another example. Distance to the sun. The distance to the sun is 1.5. Once again, you want to put this in scientific notation. 1.5 times 10 to the 8th. Well, 1.5 times 10 to the 8th is closer to 100 million, if you write it out with all the zeros, than it is to 1 million. So because it's, I believe, well, let's double check that. Yeah, the 1.5 times 10 to the 8th is 150 million kilometers. But you don't really need to worry about that. When you do these, basically, if you put these in scientific notation, this second part here, where the multiplier for the base 10, that's generally the order of magnitude. There's an adjustment that you'll see in a minute here, but excuse me. So the order of magnitude of this number is 10 to the 8th, which is 100 million kilometers. Order of magnitude. That's how big it is to a gross approximation. Here it is written out, 100 million as opposed to 1 million. It's closer to 100 million than 1 million. Here are some other examples. If you have, well, here we go. We have a decimal number. And we'll just show you the shortcut now. Put it in scientific notation, 0.0002700 sig figs. In scientific notation is 2.700 times 10 to the negative fourth. I really don't care about the sig figs right now because we're rounding off. But once again, if this number right here, the 2 is less than a 5, basically this is the order of magnitude, 10 to the negative fourth. That is the order of magnitude of this number, 10 to the negative fourth meters. But let me give you an example. If you have 0.00087, which is 2 sig figs, once again, just to practice sig figs, it's 8.7 times 10 to the negative fourth meters. But in this case, the order of magnitude, okay, is 1 higher. Actually, let me come back. Well, I'll finish this one. Because 8.7, if this number right here, this first number ahead of the decimal is a 5 or greater, you have to add 1 to this 10 to the negative fourth, or to the negative 4. You got to add 1 to negative 4 to get negative 3. So the rule is the order of magnitude is the base 10 multiplier unless the number in front of the decimal is a 5 or greater, then you add 1 to the exponent. Here's another example, part C. 56,800 kilograms, 3 sig figs, as practice, but 5.68 times 10 to the fourth. Once again, this is a 5 right here at the beginning of the scientific notation number. If that number is a 5 or bigger, you add 1 to that exponent there. 10 to the fourth is 10 to the fifth. So this number is close to 10 to the fifth in magnitude. So what's a little tricky here is like when you have a negative exponent, when you add 1, it looks like it's getting smaller, but it's not. It's getting bigger. 10 to the negative third is bigger than 10 to the negative fourth. So that's order of magnitude. We'll talk more about that in the homework. Now, lastly here, comparing numbers. Comparing numbers, there's 3 basic ways to compare numbers in physics. Like even in a lot of other classes, you have to compare and contrast. You're not really going to be doing compare and contrast here, but we're going to be doing numerical, quantitative comparisons, like how much bigger is one number than another. There's 3 basic ways to do that in physics. One way, or in math, one way is what's called absolute difference. Oops, sorry. Oh boy. Okay, I seem to have dropped my pen there. All right, so absolute difference. There's absolute difference. Subtraction, we'll talk about that. Percent difference is probably the most common comparison technique. You'll be doing that in labs most likely. And the equation for percent difference, let me change colors once here. Let me get fancy. Let's go to blue. So in this blue circle, that's going to be important to have written down in your notes. Well, it's in the notes right here, but somewhere accessible in labs, you want to find a percent difference between your result and somebody else's result. You take the final minus the original, the absolute value, that's what that means there, divided by the original or the reliable number. I'm going to give you an example in a minute. So that's going to be probably the most common way to compare numbers in physics. I'll go back to red. All right, and the final one to comparing numbers is using the order of magnitude to compare numbers. So let's talk about this. For example, if you have an article of clothing that was marked down from $15 original to $13.85 final price, compare those 2 numbers. Well, you can figure out the absolute difference, which sometimes is important. You want to know what your discount was. Well, that's basically just take the 15.50 minus 13.85, which is what, $1.65. So in other words, there was a $1.65 discount on that article of clothing. So you're saving $1.65. So that's one way to compare things. You can do that by, like what's the markup or what's the markdown here. This is the markdown. So you're saving $1.65. But what's the percent savings? What was the percent markdown? Well, the percent markdown, so that was the absolute. That was the absolute. So now I'm going to do a percent. So I'm going to use the equation from up here. The percent markdown, the percent, you subtract. You take the final number minus the initial and then take the absolute value. So the final number is 13.85 minus the initial, 15.5, and you take the absolute value. Those symbols mean absolute value, divided by the original number. The original number is 15.5. You can do this in business to figure out what percent your stock portfolio went up or down. This one went down. So technically, if you didn't take the absolute value, you get a negative here. There's a markdown. There's a negative. There's a loss. But here it's a savings for the customer, but it's a markdown in price. We're going to take the absolute value, though. So we take 13.85 minus the 15.5. That's the 1.65. I'm a little out of space here. So sorry about this. I'm going to erase that and then put in the calculation. So you'll have to keep that down, though. Keep that in there. So when I subtract those 2 numbers, I get 1.65. Take the absolute value was negative 1.65. I get positive 1.65. Then I divide that, and I get 0.1065. Well, 0.1065. Oh, you got to multiply by 100. So there's the multiply by 100 to get the percent. So I got to take that times 100. I'm going to kind of magically put that in there. You got to remember to do that. It comes out as 0.1065. But if you multiply by 100, that equals 10.65%. All right, so my markdown in this case was 10.65% markdown or loss. That was what my savings was. That's 4 sig figs. You can do 4 sig figs there. Actually, probably 3 sig figs because the 1.65 was really only 3 sig figs. So technically, you should only have 3 sig figs. I'm not going to get real tight on the sig figs on this. I actually would have just put 11% 10.7% markdown. Whoopsie. I don't know why I did that, but let's go back up here. 10.7% markdown. Like I say, I would have preferred even to say 11%. Even if you put 4 sig figs there, really not quite right, but I would have taken that as well. Okay, last example. Well, actually, then some practice on SOHCAHTOA. If you want to compare numbers that are far apart, okay, percents make no sense, and absolute subtraction makes no sense. For example, down here we have some numbers that are far apart. We have a big number and a small number. I want to compare these two numbers. So I have 5.72 times 10 to the 11th, which is a very, very big number. The other number is big, but it's not near as big, divided by 3.66. So the rule here for comparing numbers that are far apart like these two, they're orders of magnitude apart. In other words, 10 to the 11th is 5 factors of 10 bigger. So there's really no sense of making a percent comparison here. But what you do when you compare those two numbers is you take the big number, and this comes with practice, divided by the small number. That's 1.57 times 10 to the 5th. 1.57 times 10 to the 5th. And there's no units there because you divide meters by meters. There's no units. That's a comparison of how much bigger the big number is. But what you normally do is you just then look at the multiplier, the order of magnitude, and you would say something like this. Well, the big distance, D2, I'm going to call this D2, distance number 2. And this is distance number 1, D1. Small number. So I took the big number, D2, divided by the small number, D sub 1. And basically, D sub 2, the way you would normally say this is you do a squiggly equal sign. D2 approximately equals 10 to the 5th times D1. In other words, D2 is 10 to the 5th times bigger. 10 to the 5th is 100,000. D2 is 100,000 times bigger than D1. That's the way it's typically done. Another example. Look for the big number divided by the small number. If they have orders of magnitude difference, I have a 10 to the negative 4th, a 10 to the negative 9. So percents here make no sense because the big number is way bigger. The 10 to the negative 4th is the big number. It's bigger than 10 to the negative 9th. So I take the big number, 1.72 times 10 to the negative 4th, divided by the small number, 2.12 times 10 to the negative 9th. The meters would cancel out. You don't worry about units here. And you get an answer there of 8.11 times 10 to the 3rd. 8.11 times 10 to the 3rd. Times bigger, but once again, the 8 is bigger than a 5. So the multiplier here is, the order of magnitude bigger is 10 to the 4th. In other words, D2, the bigger number, and I'm going to put my squiggly equal sign. So because we're just doing gross comparisons here, is roughly equal to 10 to the 4th times D1, the smaller number. Or if these are velocities, you say V2 is roughly 10 to the 4th times V1, because these could be velocities or masses, or these are both distances, but I could have used any units here, but they have to be the same unit. They have to be both meters or both kilograms. They have to have the same units before you divide them. So make sure you have them in the same units before you compare them. Okay. So, and once again, this was D1. D1 is the smaller number. D2 is the bigger number. All right. Finally, a review of SOHCAHTOA. Hopefully you know this from Trig. I'm going to put the numbers in here. I'm going to go kind of fast because this is going long. But it should be a quick Trig review, and you should have a calculator that does this. But here's a triangle. There's a right angle right there. Let's say this is 56 degrees. 56 degrees. I'm looking to find x, and this is 16 centimeters. So I want to find x using SOHCAHTOA. Hopefully you're familiar with this from your geometry class. But we're going to review this because this is going to come up several times this year. But in this case, what I'm going to look at is, okay, do I want to use sine, cosine, or tangent? So this is the hypotenuse. It's always opposite the right angle. This side right here, the x, is adjacent to the 56 degrees. So I'm looking at the adjacent leg, the length of the adjacent leg, and the hypotenuse. That involves cosine. I'm going to use cosine in this problem, because the leg next to the 56 is adjacent to the 56. So I'm going to say cosine of 56 degrees equals the x, adjacent leg, divided by the length of the hypotenuse. I want to see that written out. When you do these for homework, write that initial equation out. It's an equation with an equal sign. Don't add or subtract anything to it. In the perfect world, you could just give me the answer right now. But basically, if I show you the extra step, But show that circle there. Show that equation that shows me the initial setup, which function you're using, sine, cosine, or tangent. We're not going to get into the law of sines, law of cosines. That's extra. That's a little bit deeper. But in other words, x here is going to be equal to, if we multiply both sides by 16, x is going to be 16 times the cosine of 56 degrees. So x equals, and then hopefully you have your scientific calculator. And make sure you're in degrees, not radians. But you type in cosine of 56, or put that in parentheses. Cosine of 56 comes out to be, I didn't write it down, but comes out to be some decimal number. The calculator will give it to you, and you multiply that by 16. And when you do that, you round off to 2 sig figs, you get 8.9 centimeters when you multiply those numbers out. So if you need help with that, we'll have to do a review session in office hours if you've forgotten how to use your calculator. But punch in cosine of 56, some decimal, it's like 0.6 something or 0.5 something. And it'll give you 7 sig figs, but we want 2 sig figs because the numbers we were given in the problem are 2 sig figs. Another example, there's a right, shoot, I gotta go back to that, I lost it. Okay, second example is this one here. Let's say now we're gonna be looking for theta. So we got to do a kind of a backwards computation. We got 24 meters. That's 24 meters. This is 19 meters. And I want to find theta. So, okay, that's a theta right there. Okay, so what I notice in this case is that I have the two sides that make up the right angle. They are the adjacent and opposite legs. They're not a hypotenuse. So I'm going to be using tangent for this problem. The 24 meters is adjacent to theta, and the 19 meters is opposite to theta. So I have the opposite. I misspelled it up here. Oh, you know, there should be an E up there, obviously. No big deal. But I want to use tangent. So the equation you want to use in this case is tangent of theta is the opposite length, 19 meters. You don't need the units. Then make sure they're the same unit, though. They're both meters, over 24. All right, so this one's a little trickier because you have to do what's called the inverse. And you can type it in. You can do the division right now and get, you know, tangent of theta. This is a little extra work. You don't need to all, well, this is what I'll be looking for when I grade these for homework. Like, you set up the original equation, then whatever you do or comfortable with. But if you do the tangent of theta here, that comes out to be like 0.79. 2 sig figs is what you want. You can retain more sig figs, but really it's just 2 sig figs right there. And now what you have to do is the inverse tangent on your calculator. Once again, I'll have to help you with that if you forgot how to do that in your calculator. But basically it will look like this. You don't need to write this step down, but theta equals tangent -1 of 0.79. Okay, that's inverse tangent. So on your calculator, you have to hit the inverse tangent button. There's a button on there. It's usually like a up for TI-84 or 83. It's in the upper left. You have to hit the second function table. In other words, you're doing the problem backwards. So you're not doing a sine of an angle. You're doing the angle that's the sine of, that you have the sine of already. So on your calculator, it does look like this. It looks like it'll say tangent -1. So you just type it in, tangent -1, 0.79 in the calculator. It'll look like that when you plug it in the calculator. And if you do the math there on the calculator, it comes up to be theta equals 38 degrees. Once again, 2 sig figs is enough. Well, it's really the correct way to do this, 2 sig figs, because the original data had 2 sig figs. All right, hang in there. We're almost done. 2 more examples. All right, so how about this one? This one's, you might think of this one as a trick, but x, these could be, I mean, I can use any letter here. I can use, let's use y. It doesn't really matter what it is. And 25 meters. All right, once again, make sure those are both the same units, whether they're meters or centimeters or miles or they're not going to be kilograms. These are usually dealing with distances. Sometimes with speeds. We'll talk about that when that unit comes up. But we're looking for y. Now this one's tricky because it's not sine, cosine, or tangent. Hopefully you remember that this is a direct application of Pythagorean theorem. A squared plus b squared equals c squared. So I'm going to review that. So make sure you watch out for that one. It's y squared plus 18 squared equals 25 squared. 25 is the hypotenuse. The 18 and the y are the 2 legs. So that's the famous Pythagorean theorem. A squared plus b squared equals c squared. So it's going to be y squared plus 18 squared. 18 squared is what, 324? Let me double check that. 18 squared, 324. And that's 625, I believe, 25 squared. So y squared equals, what, 301. And then if you take the square root of both sides, you get y equals, once again, round off to 2 sig figs because the numbers have 2 sig figs, 17 meters. All right, so that wasn't even sine, cosine, or tangent. It's a review of Pythagorean theorem. So watch out for that. And finally here, this one, let's say this is the toughest one. This is 40, let's say this is 42 degrees. Let's call this x. That's my hypotenuse. Let's call it, just call it h for this time. It doesn't really matter what the letter is. H, or hypotenuse. And this is 55 centimeters. For some reason, I'm stuck on 2 sig figs. This is 2 sig figs. You should round your answer off to 2 sig figs. A lot of things for homework will be 2 sig figs, or 3, sometimes even 1. But this case, looking for h, the 55 is the opposite leg to the 42. And h is the hypotenuse. So I'm going to be using sine in this case. I'm going to use sine of 42 degrees equals the opposite length, 55 over h. Now this one's tricky because the h is in the denominator of that fraction. So one of the rules, the shortcut is, if that ever shows up, the shortcut is you can switch the sine 42 and the h. In other words, bottom line is if you multiply both sides by h and divide by sine of 42, but the shortcut is you can switch those two. Well, I'm going to be looking for this in the homework. I'm going to be looking for this. Write that out. And for those of you who are good with the calculator, just give me the answer. All right. The answer is going to be more than 55. The hypotenuse is always more than the short leg. So if you get an answer less than 55, something went wrong. Make sure you're in degrees, once again, not radians. But bottom line is h is going to be equal to, here's the shortcut. You can just take the shortcut over the sine of 42. You can switch the h and the sine of 42. So h then is just going to be, and make sure you take 55 divided by, and you might want to put parentheses around the sine 42. But if you do that in this case, once again, rounding off the 2 sig figs, it comes out to be 82 centimeters. All right. Well, congratulations. Thanks for sticking in there. That's a long one, 45 minutes. Good luck with that. And we're done with Unit 1.